Hi, welcome to the first Ask the Expert live session. We have a Q&A session with Dr. Michael O'Mahony, the Sensory and Consumer Sciences Achievement Award for 2017. So we intend this session to be kind of like an office hours where you can ask your questions live and have a discussion. Feel free to use the webcam if you would like. If you see on your right-hand bar, there is a video icon, and if you click on that, it says share my screen, share my webcam. And if you can remain on mute when you're not asking a question, we would appreciate that. And so just a little bit of background about Dr. Michael O'Mahony is that he's a professor emeritus at UC Davis. He's the author of Sensory Evaluation of Food and Statistical Methods and Procedures, editor of Harvey's Bibliography of Taste, has over 200 journal publications, and has conducted too many short courses for industry and academia to fit on one slide. And so the IFT's Achievement Awards recognize an individual or team for remarkable contribution in research, applications, and service to the food science and technology industry. So to recognize excellence within the field, he received the Achievement Award in 2017 for his leadership and contributions in identifying models that form an underlying theoretical framework for the fields of sensory and consumer science testing, their assumptions specifically in the area of experimentation and adoption of Thurstonian models. And so without any further ado, as I mentioned, over 200 journal publications, so it's quite a lot to cover in one slide. So I'll hand it over to Dr. O'Mahony to answer questions. And if the callers don't have one, I do have a few that were sent in ahead of time, but I'll let the callers ask their questions first. So thank you.
Hello, Janine.
Hi, Mike.
How nice to see you.
It's good to see you too.
Don't ask me too difficult a question. Janine was my PhD student once. Were you PhD, masters? I can't remember. You were one of my. No, you were my.
No,
master.
just masters.
Sorry about that.
No problem.
Fire away.
So I guess I'll get the ball rolling here. I didn't really have anything prepared, but I just wanted to hear your thoughts. A lot of times what we are doing in industry is racing against the clock, trying to do things faster with as little possible data as possible. Yeah. And a lot of times for early phase in the project, we end up deciding which possible products to follow based on some sort of internal screening. There's advantages and disadvantages to that. What are your thoughts on that kind of approach?
Okay. When we do our research in our lab, if we screw up a bit, we start again. And what we try to do is to develop the best method you can. That is, if you wanted really precise data, this would be the method to use, in fact. Fine. At the same time with our students, we try to get people to understand how the brain processes information and how the senses work. Basically, how does your machine work? Right. So you have to figure out exactly what it is you want to know, and quite a lot of people jump into sensory science without, they're just doing descriptive analysis because, you know, that's what you do, isn't it? A bit like that. So you have to figure out exactly what you want to know. And most people talk about a workbook or a workshop or a workbox or something of all the tests that you can use. And then you go to that and you say, oh, I'll take that one there. But that's not a very good way of doing it because they're not all the same. So what you need is really education. You need to know what happens in the head when you're doing these tests which ones are more powerful than others, etc., where the biases are, etc., etc. So, okay, you have a problem. So now you could use one of those tests or design a test yourself. The problem is the tests don't work with everything. You can't test jalapeno peppers the way you test tomatoes. It's quite different. The peppers just burn you. So you may have to invent it. So you do the best you can. So you try weekend to get the very most sensitive, powerful, sure test that you can imagine. Fine. And that's what we do. Now, if you're in industry, people want the results yesterday. So you often just don't have the chance to do all that. So what you do is you get as close to what you think the ideal test is. It may not be very close, but you're trying to get as close as you can to that. But then you bear in mind that what you're doing is now going to be rather more approximate. It's not going to be so absolutely exact. But that's fine. If you know that your measurements are approximate, then you can make sensible conclusions. It's when you think that approximate measurement is absolutely terribly precise, that's when you're going to run into problems. So I think the thing is, you make shortcuts. The more you know about how the human system works, the better your shortcuts will be. There's no substitute for knowledge. So you will probably make more sensible shortcuts than other people who didn't know quite how people work, in fact. So you make the most sensible shortcuts you can. And then when you're interpreting your data, then, okay, you bear that all in mind. And that's really all you can do, because you're working under the hammer, in fact. So you can't actually practice your science properly because the people who are your bosses don't realize you need to. And so that's one of the big things, which is a bit of a shame, because often, excuse me, this is terrible, often the measurements you make, which is often, do we think people are going to buy this, is probably the most important measurement you do. You get as close as you can to do we think people are going to buy this, but there's lots of ways of doing it. And if you're sensible and educated, that's terribly snobbish to sound to say, but whatever. The more you know about it, then the shortcuts you make will let you give a sort of fairly idea of whether people are going to buy it or not. But you might have done some really terrible method. And so you can say, it's very possible that it might just happen that someone might want to buy this, but none of the methods have actually tried to do this. One of the problems is the methods that we use, we're just assuming they measure what we think. So for instance, people still use a 9-point hedonic scale, the verbal version, to see whether people are going to buy things. Well, the assumption is if they say they like it extremely and like it very much, they're going to buy it. But you can like things a great deal, but not buy it. And so strange, wouldn't we ask, are you going to buy it rather than do you like it? So, but I think people didn't do that. They used the 9-point hedonic scale because it was the only thing around at the end of the Second World War. And people didn't have degrees in sensory science. So they just thought, well, what do we do? And they seem to have spent a lot of work on doing it. So it must be the best, really. So it's people who don't know too much about it using the measures. But I mean, you put me in front of a gas chromatograph. I took my chemistry degree a long time ago, and I don't think I'd be very good. So I would just do what I was told. But when you do research in it, you can fool around a bit, really. And you can fool around a bit because you know a lot about it. So there we are. Does that answer your question? I
think so. It raises some others. If no one, I can ask another if no one else has any questions.
You go
on. So one of the points you bring up is we do an awful lot of asking people questions with a 9-point hedonic scale, which I agree is, we know it's a very poor predictor of repeat purchase. It's a poor predictor of purchase. I'm not sure how much better asking people directly likelihood to buy is. I know you've done a little bit of research with that. Have you shown that to be a better predictor of initial purchase or repeat purchase? No, we haven't.
Okay. In fact, these tests on the whole have never really been tested properly for seeing what they predict. Now, we've done something with a 9-point hedonic scale to see whether it predicted purchases. And the way we did that is we gave some people some yogurts. We gave it to them blind. And then we gave it to them with the packages that they came from. Not saying that that's the same thing. We didn't tell them that. We just said, we're interested in the sort of background of things you buy anyway. And so how about these? And these were the ones that you could get in the shop. And these are the ones that they bought. So we wanted to see, by following them up for a year, because people came and visited them every year to get all their receipts and gave them nutritional advice. That was the reason that the whole thing, that was our cover story, and that's what we did. Then they got nutritional advice. And advice on all sorts of other things too, in fact. So there was a full-time person doing this for their PhD. And so we found that it was a pretty poor predictor of what people are actually going to buy. If they'd known, or if they had the packages that it came in, then it was a better predictor. But being strict, not very good. But if we were very lax, what happened was that the thing that came top on the scale that they had, we gave them a likelihood to buy and also the normal 9-point hedonic scale. If a thing got the highest score, then if what they bought was that one and another one, we still say, okay, it predicts. The other thing was if 2 got the highest score and only 1 actually was the one that they bought, it predicts. So we're a little bit more lax there. And what we found was maybe when you've got the labels, because people, when you test them blind, it's a very bad predictor. But when you test them with the labels, maybe you might get about 60% success on getting the number 1. But the one that came second or third weren't bought a second amount of time or third amount of time. So actually, with all the scales that we got, we actually did no better than asking them, which one do you like the best? And you can do no more than that, because that's all that you can get out of it, really. But 60% for this one. Now, it's going to depend on the food. These were middle-class people in Veracruz in Mexico, in fact, where money wasn't so much the motivation for buying it. Although we did correlate it. I apologize for this. This is terrible. It's going to be forever and ever on a movie somewhere with Omani coughing through the morning. Okay. We could say that, yeah, if this is what we seem to get, again, it's no better than just asking people, which did you like the best? Because that was the only thing that correlated it with anything at all. And it was for those particular people, those particular foods, which were strawberry yogurts and that particular time, etc., etc. But that's all that's really been done. The army did a couple of things, and there's some people in Italy did something with kids with in a school, predicting what they'd had in their school lunch. I forget their names. I apologize to you, whoever you are, for forgetting your name. So that's 4 things that have been looking at some form of predictive effect of the 9-point hedonic scale since 1950s. We're now 2017, and only 4 groups or only 4 experiments have been done to see whether the 9-point hedonic scale predicts anything. That's disgraceful, in fact.
Well, it's probably that some studies have been done, but they aren't published, and maybe that's what you're getting at, is that it's difficult at a university setting to track things like how much purchase occurred and compare that to the liking score. Because in industry, you can find out what your, how the product tested before you launched it. You can see how well it sells, and do that kind of cross-group sort of validation. But you don't publish it.
Yeah, yes, it would be nice about that, but I can understand. So yes, there might be a wealth of information there, in which case I'm happy to know that there's a wealth of information there. At least someone's doing it, at least.
Right.
Okay, I guess you've had your time.
Yeah, I'm going to wait. I'm going to make someone else ask a question.
Yeah, we did have a question that was sent in ahead of time. And so R&D asked to do replicate consumer acceptance testing, but sometimes the trend is different and they want to have an explanation for why.
Okay.
And I don't have a lot of other details.
Yes, it's a bit sort of hanging in the air because it depends on the exact way that people did it, in fact. And so they do it. But one thing can be the way you run the acceptance test, basically. That's one possible. Acceptance can mean all sorts of things. It can be a rating scale. It can be a preference test. It can be all sorts of things. And there's all sorts of pitfalls there. With preference tests, again, not many people have actually done anything in the way of seeing whether preference tests predict anything. We're running a project at the moment, and we've finished one project. We're on project number 2. Project number 1, we gave people a choice of a couple of chips, in fact. And generally, the literature says that any form of prediction is not going to work very well. So you can ask people what they prefer, and you know, they just keep changing their mind all the time. So you know, it's pretty well hopeless almost to try. It may be hopeless to try, but I think we could try and measure how bad or how good it is, really. We were rather surprised. We used about 3 or 4 different tests to start off with, and then for 3 months, people came and just chose the things that they were tested on. The test was, which one would you choose? We didn't ask you which one do you prefer, because prefer's not actionable, really. It doesn't predict behavior. But choosing is behavior, and also buying is behavior. But buying was going to be a bit more complicated. We have to own a shop or something like that. So choosing was better. So the preference tests were, you know, which one would you choose, this one or this one? Or I would only choose this one and never choose that. Or I'd probably choose this one more than that. Or they have a little scale. All sorts of tricks we did, in fact, all types of doing it. And then we looked to see what happened. And it was interesting. I wasn't expecting this, but people stayed very constant. About 50% of the people who were tested, which is much more than I expected, stayed constant through the 3 months. They were tested 9 times, at first every week and then every 2 weeks. So every time they did, they chose the same thing. So it was a bit more constancy than I expected, except some people were constant on the thing they chose, but other people swapped the first time they came back, and then were constant evermore after that. I thought, that's interesting. Why did they swap? Well, when they were tested, it was in the lab under lab conditions. And we wanted to make it like real life, because we're trying to predict real life. And a lot of the people who've been doing these experiments is they test you in the lab, and then you come back and you're tested again in the lab, or you did it in the same session, but you just stayed in the lab all the time. So I thought it would be better that we change the conditions and look at what they're like in real life. So we test them in the lab, and then we test them or see what they choose, in fact, in real life. So for real life, we just had a couple of great bowls of these chips, in fact, and people could come to an office. It was on the campus, but it wasn't the lab. It was at a different place completely. And they could just pop into this office and grab some chips and go away. It really was like that. And we could see which one they did. And so the surroundings changed. The extraneous factors changed, in fact. And so it could be then, on that first time that people came in, the extraneous factors were nudging them to change. Or not nudging them to change, but I mean, it was the extraneous factors said change, in fact, so they changed. At least they changed when the extraneous factors were there, or the surroundings had changed completely. And so maybe it isn't so much that people just change randomly all the time. It may be that they're urged to change by the extraneous factors. That is, they're urged to change by a change in the environment, basically. Mm-hmm. So we found also, this is different research, when we did preference tests with identical stimuli. That's quite fun, because people say, oh, I love this much more than that, and they came out of the same bottle. It was that. But you can get about, maybe about 30% of the people will say, no, I don't particularly mind. But the other 60, sometimes 80% say, oh, yes, I've got a preference here. When it can't be fired, that preference, by the sensations they're getting from the food, because it's the same. If it's a slight difference, maybe due to adaptation or something like that, that's not a big enough difference to elicit a preference, because we've done experiments. You've got to have a fairly big difference to elicit a preference properly. Small ones don't do it. So, again, one theory is that it's extraneous factors. That is, people are working on autopilot, fast thinking. Here we see, oh, those are two things, right, which, so what I'm meant to do is taste them both. It must be different, of course, because otherwise they wouldn't be testing me. And they'd probably like it if I came up with a preference. And they sort of work on autopilot like that. But if you change the extraneous factors, you change the test, so it doesn't look like a preference test. And instead you give them 3 things. Two are identical, that's what we call our placebo pair, and there's a third one. And so we say, okay, taste these. Now, you may find you like two the same and one more. Of course, it has to be the placebo pair, which is ones they like the same. You like two the same and one more, or you like two the same and one less, or you like all three the same, or you like them all differently. If you like them all differently, then that person says they have a preference for the placebo pair, which normally about 80%, 60% of the people do. Then we don't know whether we can trust them when we give them a target pair, different things. But in this case now what happens is more like 80% of the people say they don't care about the placebo pair, the two that are the same. So the factors are the same, and their behavior now when they're tasting identical changes, in fact, because it no longer looks like a preference test. So we never thought this would come off, but we saw this an interesting experiment, which was done on eating popcorn in the movies. And they would give people to go into the movies and watch trailers and things like that. They would give people, half the people who went in there had stale popcorn and half had fresh. They had regular popcorn eaters, they had medium popcorn eaters, rare popcorn eaters, etc., etc. People not used to popcorn didn't really eat much of the stale stuff, but the people who were less regular eaters just carried on eating automatically, whether it was stale or not. And they knew it was stale, but they just carried on eating it. In fact, they could taste it was stale. However, if then they had to eat it with their left hand, so this is not what they normally do. This is their right hand. They just sort of keep on doing sort of like this and all the time. But if they had to do it this way, it was different. Everything had changed. And so then they weren't eating really so much of the stale stuff now. They were sort of being taken out of their automatic thinking and dreaming or whatever it is, and started concentrating on the popcorn. So if you change the situation, it could be that people's behavior or preferences can change. Now, this we don't know, and we're running an experiment at the moment where we've got tests where we're controlling for the extraneous circumstances, like doing that three stimulus triangle test. That's that type of preference test. We're running those at the moment just to see what happens, because if we've got rid of those extraneous circumstances or the distractions or making you work on autopilot, maybe we could be showing that yes, it's extraneous stimuli that trigger the change. If that's so, then it means that if you're putting a new product into the shops, then that's the time that you really need to hit them. You need to change the environment of the shop around where you're presenting yourself. Have a very good presentation, because that may get people to be tempted to change and try it out, in fact. So, you know, it's a lovely theory, and when we do our second experiment, we may crash it completely. So it was a nice idea, but it's not true. But it's worth trying, because it does have some implications. I don't know whether that answered the question or not.
I think, you know, I think that one of the big takeaways is that environment factor, I think, and that if you're doing multiple consumer tests, even if it is the same stimuli, it's usually not the exact same set of people, you know.
Yes. Okay, yes, I remember.
And then plus
yes,
also then the environment factor. Even if you're using the same external agency, there's going to be, you know, probably different employees working, or, you know, it's not the exact same environment. It's not the same temperature outside. It's not the same weather, you know, all of those things that we don't really think about in influencing.
And not necessarily the same people either that they're testing as well.
Yeah.
So I mean, different people like different things. So you wouldn't expect consistency for preference or liking. You'd expect consistency for difference tests or intensity tests. That's a more objective thing. But liking, people vary all over the place. So yes, you might find next time you do the test, you get a different answer. But one way of looking at that is then how many people have you been testing? Because you may have, you know, several million people buy your product. So, you know, 30 people isn't a very good idea. In fact, you want to think of it a couple of hundred, really. One way to know how many you're testing, or are you testing enough, is split your sample in two and see if the both halves agree. And if they agree, you've probably done enough testing. But if they don't agree, do some more testing, really.
Mm-hmm.
Or if you can't afford to do some more testing, then make sophisticated or knowledgeable conclusions, in fact. Know that you've got a very approximate test. You can work very well with approximate test, but that's a little bit more different as consumer acceptance.
Mm-hmm. Yeah. Okay, are there, for those?
This is Judy. I was to say that's interesting. Hi.
Would you like to share your webcam?
Not really.
Okay. You're welcome to.
We'll see. But that's an interesting point, Dr. Mahoney. The whole thing of, how do you know? It's the idea of when we're working in these situations where we're moving so fast and we're moving with such short budgets and things. How, something's better than nothing, but at what point is it really not worth it at all, kind of thing? And I think that's an interesting point, what you just said about splitting your sample and seeing where you find, even if it's, does that, in your mind, does that still work if you did, let's say we did 150 people and you randomly pulled the 275, two groups of 75, or are you saying you need to do a group of 75 and a group of 75 and see if they match?
Oh, I would say, go on as, first of all, we don't know how many tests we have to do because it depends on the type of people we're testing and the product we're testing and what we're doing with them, what we're testing, basically. I mean, if I want to know whether shooting you through the head kills you, I only need to test about 1 or 2 people. I don't feel I need to test 200. So that's the extreme example, but you know what I mean. So we don't really know how many people we should test. If you keep doing it, you get a feel for it eventually, in fact. There's 2 ways of getting a feel for it. One is to see the feedback from sales, and that's useful. And if you can really get that data properly. And so if your sales go up because you've done something, okay, it's a success. And sometimes if the family dog likes it and it's a success and the family dog doesn't like it, it's a failure, use the family dog, use whatever you can, really. But yes, I would think that if you find that you've split your sample in 2, just test as many people as you think is sensible. And if you're looking at how the results are, you start noticing, oh, a lot of people prefer this one to this, or this seems to be the one that's going there. Oh, yes, it seems to be way out. Okay, let's just split the thing in 2 and see whether both sides agree. Because it could be that there's, it's a very, very clear result. And so it's going to come out with maybe a couple of 100 people. But it could be with something else. One half says one thing and the other half says something else. So this is something where it's not so clear cut. Because it depends on the proportions very much as well. You may find that 90% of the people prefer A to B, or just 60% prefer A to B. So that's going to affect the size of your sample, really. But it's a fairly conservative thing to do. People have got all sorts of funds getting around doing that, but it's about, it's the very safest thing if you could afford to do it.
Right, and I think that's the practicality of it. But I appreciate your thoughts on the, you get a feel for it, and we just have to get our business counterparts to understand that sometimes we've been doing this for a very long time, and it just, looking at the data, it just seems either there's something funny or there's something that just seems right. Yeah. Because sometimes it's just, it is experience, and that's, thank you for reaffirming that.
Okay, a lot of it's our fault because I'm a retired professor now, so I can bitch at all the other professors. But what happens is sensory science isn't taught very much. It's often not taught by specialists. People read a book and follow the book, and there we are. But the book's not always right. In fact, you read a textbook and you say, no, that's wrong. We've done the experiments. We know it's wrong, etc. But the thing is, it's not taught very much. And so a lot of management going into the companies that they go into, in fact, they don't know much about it. And so they think it's sort of two old ladies sitting in the kitchen tasting things, thinking, oh, that's nice. You know, they think it's a bit like that. Some people still think it's sort of done by wine tasters and that type of stuff. They think that you've got bread tasters or Twinkie tasters who are experts, etc., and they can predict what's going to be liked. And so they think it's all very straightforward and simple. No, it's behavioral neuroscience. It's much more complicated than that. But management don't tell biochemists how to do their stuff. And so they shouldn't really be telling you how to do their stuff, because they don't know what you know. They don't know what biochemists know. But people don't really understand that this is a science, and it's quite an exacting science as well. The thing to do is ask Michael O'Mahony to come down and give a little talk about what is sensory science. What we do is we always start off with it's fun. It's got illusions in, and Janine, I can just see you there again. She gives this talk too. It starts off and it's fun because it's full of illusions and all sorts of things like that. It's very entertaining, but it does make people think, oh, I'm not quite sure really what we're perceiving. Then you hit them with signal detection theory or Thurstonian modeling. So in the second half, they think, oh, yes, I guess this is a science. And that's what you have to do, or do it yourself. Get a lot of illusions to illustrate. There's all sorts of things like adaptation is fun. You can do visual adaptation where you give them blank screens and you see pictures and stuff like that. Or you can make the sense of taste taste like salt vanish. Give them a mild salt drink and they can taste it salty. Then fill their mouth up with seawater. That's really salty. Let them spit it out as much as they can. And then when they taste the mild salt drink again, it tastes like distilled water. Things like that. Then they realize that the senses are a bit funny. And then hit them with Thurstonian modeling. If you know Thurstonian modeling, all those distributions, world of good. They really see, oh, this is science. So, and that might help a bit, but it's worthwhile doing something like that, actually.
Right. Thank you.
Okay, bye.
If there's still time, I wanted to ask you if you could think of a workaround for an issue that I realized at some point back when I was at Ohio State. One is if we do something like the beta binomial, where you're presenting two pairs and you're asking a preference question, you want to assume that your preference is the same from the first pair to the second pair. Or if you are doing a set of, say, 5 samples and you throw one of them in there twice blind, your assumption might be that, you know, you're going to check how reliable the panel is by seeing how it does with each iteration. And that makes a lot of sense when you're rating intensity or rating similarity, you know, degree of similarity, degree of difference. But what I realized in doing that is, as you do a preference, you know, a pair after a pair, or if I'm tasting a set of 6 samples or 5 samples, that things like satiety could potentially be occurring, adaptation could be occurring, and it made me wonder if one of those extraneous factors that you can't really control is your satiety, right? Could it be that even though we're assuming liking remains constant, maybe that's an unsafe assumption, right? And that's always bothered me ever since. And I've never thought of a way to really prove that, disprove it. Or I guess the model assumes this thing that I'm just not sure is true. And I wondered if you had any thoughts on that.
Yes. Well, with difference testing, testing 2 or 3 times at once is probably a good idea if you can do it. And if you've got a program to do the beta binomial for you, in fact, otherwise it's a bit, a lot of calculations and stuff like that to do. But that's a good idea because over dispersion is there anyway. It's like interaction in analysis of variance. It's there anyway, but if you only do one of everything, you can't actually get an F value for it. And so over dispersion is there as well, you know. But if you only test the thing once, you can't get your handle on it, but there you are. But then we know, okay, we didn't measure our over dispersion, so we just measure that. We'll just keep that in mind when we're looking at our results. So yes, definitely for difference tests. Preference tests, it's interesting. We never done that. What we will do is we can give them the placebo pair and then the target pair. And then, you know, if they've got preferences in the placebo pair, I'm not really sure how much I trust the target pair. You could argue to eliminate people who give you a preference for the placebo pair because you can't really trust them. but then you would only end up with 30% of your people. However, if you use something like the triadic preference test, you'll end up with about 80, 90% of your people. But even so, when I said, well, it's reasonable if you want to, just chuck out the people who have preferences for the placebo pair. Everyone screamed and yelled, you cannot get rid of people in a preference test. You can't do that. You're not allowed to do it. Rubbish. You know, I'm testing Italians and a couple of Germans sneak in. I get rid of them. I only want Italians. And I can also argue, I only want people who are paying attention to the foods, not paying attention to something else. So I don't see anything wrong in getting rid of them. However,
right, you can also argue, yeah, if they actually truly don't have a preference, then that's not the person you need to worry about in any case, right?
And yes, so I think if you test people one after the other and they decide they prefer A, second time they prefer B, they don't seem to have a preference as far as I can see. And so okay, they're no preference people, really. I think people are no preference people. The only reason people say that you shouldn't allow people to say no preference is because way back they didn't have the statistics for it. So they had to use binomial statistics and they couldn't do trinomial statistics. But you could use something simple like chi-square. But the trouble is you're not sure, or we didn't know then, what the no preference frequencies would be because no one had done it. And then Danny Ennis came along and he found, we used a placebo pair and he found, oh my goodness, he found that when you gave them identical things, 40% went for one, 40% went for the other, and only 20% said no preference. But there's a measure that you can use, in fact. So you can give two things. You can give the placebo pair and the target pair. People say, what, give two pairs? People will never stay here long enough to test two pairs. Yes, they will. And see what happens. But people were then saying, it's not fair to eliminate somebody when they've only done one chance to get it right. Well, it's not a quiz show or anything like that. But if you find that a lot of people say that they have no preference when there's a placebo pair, identical things, then you want to be pretty careful about what your data is going to be like, because people are working on autopilot. Therefore, we spent some time trying to develop what we call disruptive preference tests, where you give, say, three things. And there's other ones as well that you can use. There's one where when people are tasting the placebo pair, you can say to people, of course, you like them the same because everybody does. That sounds like a lot of bias, in fact. But in fact, then people say, oh, yes, I don't suppose I do have a preference. Or they say, well, I think I have a preference as well. Was it very different? No. And you still have a preference? Oh, well, no, I guess not. Okay. So this is bias? No. They went into there biased to give a preference. We've just swapped the bias around. So they're biased not to give a preference. However, when you give them the target pair, which is difference, oh, they have a preference then. So you haven't biased them out of saying there's a preference, in fact. All you've done is reverse the bias, but it hasn't harmed the experiment, in fact, because it's been good for the placebo pair, but people still have a preference, a strong preference when they're tested differently, in fact. There's like a caution in their heads. So there's a way around it. So you could start arguing, well, I'll only bother with the people who say they had no preference with the placebo. However, if it's about 80%, 9%, whether you use everybody or you use just the people that were good, in fact, you're probably going to get the same result.
Okay. So it doesn't sound like you would worry too much about whether or not that change in preference rating reflected an actual change in preference due to a change in satiety or something like that. You think it's just more reflective of there not being a strong preference?
I think it depends on the product a bit, yes. But I mean, yeah, if a person suddenly changes their preference and says, well, they don't seem to have a particular preference one or the other, that is, it's no preference. Or they could take either. They prefer either, that's fine. And that's really counting no preference, really. What worries me is people try not to use no preference because they still want to use binomial statistics. And the point is, no preference is one of the results. So the silly thing is to say, we'll split the preference 50-50. Now what you're doing is telling lies. What you're saying is these people, these 10 people or 15, 20 people or whatever, who said, I have no preference, you're saying, no, they did have a preference. No, just put them aside. If you can't do the statistics or the calculation, you can only do it on prefer A or prefer B, then the people who had no preference, put them aside, don't include them, but state that these people said they had no preference. But the people who did have a preference, these are the statistics. But don't pretend they have a preference. Just push them to the side, but report that they're there. Therefore, the preference of A over B was 70 to 30, and we had 50 people said they had no preference. And that's the answer.
Is there a way to measure over-dispersion if you use a no preference option in your paired preference test?
Good question. Well, the tables for it, the probably is, but I'm not enough of a statistician to invent it, in fact. Somewhere deep in the statistical literature there might be something, but there's no convenient tables or anything for that at all. So the answer is I don't know, and I don't know how to use it, but I'm not sure I need it particularly, because I think you can ask a person once whether they prefer something, but if you want to see whether they really have the preference, then get them to come back later and see what they did, really, see what they chose, really. Because there could be, if you ask them, have you got a preference? Yes, I prefer this one. You say, well, do you have a preference? Was that wrong? Was I meant to prefer the other thing? If you ask it straight afterwards, there could be ideas they get in their head thinking, oh, perhaps I should change, really. So.
Okay, thank you.
Thanks for the question.
Are there any other questions? Yeah, there is another question that was asked ahead of time, and it's around the tetrad method for discrimination, which a lot of industry has converted to or is using more often than triangle. So the question is, what would be some of your cautions or watch outs as more of industry is using the tetrad method?
Okay, all right. The tetrad thing came up because John Ennis, who works with the Institute of Perception, who liked the tetrad because the first paper he ever published when he was a student concerned the tetrad test. So just by serendipity, when he was doing some power calculations, he included the tetrad and then thought, oh my goodness, this is much more powerful than the duo, trio, and triangle. Okay, this is the thing. The brain, when it's doing difference tests, has various programs in the head for doing it. In comes the data, and then a particular program makes the decision. Is it this one or is it this one? Which is the stronger one, or which is the sweeter one, or which is the one that's different, or whatever. But there's a program does that. There's one set of programs do it for when you don't specify what the difference is. That's with your triangle and duo trio. There's another sort of program that does specify or works when you specify what the difference is, and that's the 2AFC, 3AFC, sort of the paired comparison, or a three-point comparison one, or 4AFC, 5AFC, 6AFC, and there's lots and lots of AFCs. Okay. Well, it turns out that your 2AFC and 3AFC are much more efficient than your duo, trio, and triangle. And so you can say for a given D prime, that's a measure of the degree of difference, or how different a thing feels to people. It's more a psychological thing. A particular test, or the program that the test is using, let me see, the number, the size of your sample or whatever, but let me see, a D prime, the type of test, the power that you would like, etc. And the sort of test that you've got. You can then see or project what the sample size you require is. Now, if it's a 3AFC, you may need 30 people. If it's a triangle test, you may need 300. And if it's a tetrad test, maybe 120 or something like that. So the tetrad test is nowhere near as good as a 2AFC or a 3AFC, but it's much better than the triangle and duo trio. So that's what was found. That is, what goes on in the head is a bit more efficient for the tetrad test than it is for a triangle or a duo trio. Okay. Should you just drop the triangle and go over to the tetrad? Well, first of all, I always ask people when I give short courses, why are you using the triangle test? Because I like to show that the number of people you need to show significant difference, and it's horrifyingly different. They're gobsmacked. Which is much better than teaching students here, by the way, because they just say, is that going to be on the exam? It has no dramatic effect on them at all. However, you say, well, it depends on the people that you've got. People moved over to the tetrad because it was more powerful or more efficient. But it has a problem. You have to deal with 4 things rather than 3. And dealing with 3 isn't as good as dealing with 2. For instance, you do better on a 2 AFC than a 3 AFC, even though the 3 AFC has a more efficient program, because of effects like memory and adaptation and stuff like that. So the more you have to remember, the worse it is. The more you have to remember, the more stimuli you have in a test, the better it is for statisticians. They love it because your chances of guessing go way, way, way down. So if you could do a 9 AFC, that is 9 things and one's different from the others, or one's going to be sweeter, the others won't be so sweet. A statistician loves it. He thinks that's great because you get such a high chance of not being able to guess, etc., etc. So it's efficient in that way. Your guessing chances are so low, so surely it must be right. But psychologically, the opposite is true. The fewer stimuli you have, the better it is, because you don't have to remember things. So using a tetrad test, yes, it is more powerful than the triangle test, but you can have memory problems. Some people can go through a triangle test beautifully. Others they can just about get through a triangle test, but tetrads, some people go through it, some find it really difficult to remember that 4th thing. So there's difficulties there. So it's potentially more powerful, but it depends on your judges, basically. If people don't have much of a memory, it may not be so good. Now, the model, the calculation is, if compared to a triangle test, your D prime goes down by more than 1/3, that is, if you had a D prime of 1.5, and when you do a tetrad test, it's less than 1, so it's gone down by more than 1/3, then your triangle test is more powerful. So the tetrad test, yes, it's more powerful, but try it out on your people. Don't just jump into it, because it may not be, because people just may not have the memory to do it. I'm not much good on that. You know, I find it very difficult to remember what the 4 things were, but I'm a bit old and groggy, etc., etc., so that may just be me, but I've never had a good memory. Whereas I have a student who, they can just seal through it. They could do 5 things, in fact, and still remember perfectly well. People have different memories, and people are variable. It's all to do, you know, with the amount of rinsing you should do. Do a lot of rinsing if people can remember what the first thing was that you tasted and you're going to compare it with the second. But you don't have such a good memory, don't do loads of rinsing. It's, you know, people vary a great deal. So for some people it may be better, for some it shouldn't. So all you can do is suck it as see. That is, the people that you're going to test, if you've got a regular panel or something like that, then give them the test and see what happens. We are developing a test where you only have 2 things and you don't have to tell people what to look for. I mean, the idea of using the triangle and duo trio test is, okay, we don't want people, we're not going to tell people what to look for. We want them to discover it for themselves. That's often used with consumers, but not necessarily so. You could do a 2 AFC with consumers if people could understand what you're talking about. So you could have a fruit or a drink or something and ask people which is the sweeter of the 2. That's a 2 AFC, and that's much more powerful than a tetrad test. If it's sensible, a question that people might ask in real life, then you could probably use a 2 AFC, really. Is this saltier than that? Do you find this a bit too salty? Or we talk about that in real life. Isn't that food a bit salty? Or this is sweeter, I like it. Or I don't like it, it's too sweet. So people know what those things are, so you can use a 2 AFC there because it's a legitimate question. But if you want to know whether it's more fruity, fruity can mean many different things. And so people would need to know what you meant by fruity. So it's easier probably to say which is the odd one out. Or maybe you just don't want people to think of what they'd be looking for, so you just want to see which is the odd one out. I mean, it just depends exactly what you want to do. But if you don't want to tell people what to look for, then the tetrad is more powerful than the triangle, but try it out because it has memory problems. Now we're trying this new one where we've got this self-specified 2 AFC. It looks as though it's working well, but it sure as hell beats the tetrad test. However, we're not really making a lot of fuss about it yet because we want to do more testing on it, because the poor industry are just getting the idea that maybe the tetrad can be an advantage over the triangle test. but I don't want to come out sort of the next week and say, hey, this one's even better. Everyone's going to think it's like nutrition, everyone changing their mind. So we're just holding it back a little bit until we're much surer of our results. But at the moment, we're doing it against the tetrad versus the self-specified 2-AFC, and we're finding quite a lot of people getting difficulties with the tetrad. So the tetrad, yes, can be better, but make sure your people can remember it. We did it when people couldn't retaste. Now we're doing it when people can retaste, but they're still doing as badly. So we'll see what happens. So the tetrad isn't the end of the story yet. Does that answer your
question? But potentially, yeah, no, it does. And I think discrimination is used often when industry where you don't want to see a difference. But it could explain where potentially if things were tested in both preference and discrimination, you may see a difference with preference and not in tetrad from potential memory or fatigue, because it's a two sample preference. The test is so different there.
Yes, people still say you can have a preference when you can't tell the difference. That's rubbish. I mean, it's logically nonsense. And when people what often happens is they use a triangle to do the difference test and a paired preference to do the preference test. Well, the paired preference is a 2-AFC, and the 2-AFC is much more efficient than a triangle. So all you're showing is a 2-AFC does better than a triangle test. But the way you've run your 2-AFC is by asking for a preference, not which is the sweeter of the two.
Yes.
Which you prefer. Same thing. So all these people who've said, that you can have a preference when you can't tell the difference, they should be careful. They say people will report a preference when they report they can't tell a difference, in fact. But it just depends on the test that you're doing, in fact, really. So if you did a 2-AFC difference test versus a paired preference test, then you wouldn't find you get a preference without a difference. You probably find it pretty comparable.
Hey, Micah, this is Charming.
Yes.
I do some modeling work of
hang on just a second. Can I just ask the person we were talking to, did that answer your question?
Oh, sorry.
Yes. Thank you.
Okay, sorry. Okay, Charming, sorry about that. Okay, Charming.
No problem.
Waiting for you.
I do some modeling work of liking or hedonic versus instruments. And I have to deal with different populations, the American and the Europeans. And just asking you whether you have any tips or hints on how to do it better.
Yes, if you prepare hedonics with instrumentation, there's a middle bit that's left out. It's the differences. So instrumentation will pick out differences between the foods, and then that would be what you correlate with how well people detect differences, because that's more likely to have a one-to-one relationship. Whereas hedonics doesn't have a one-to-one relationship with differences. So for instance, if your instruments can detect A should be stronger than B because it has a different set of chemicals in or whatever, it's more concentrated or whatever, then that's likely to correlate with people who say A is stronger than B or is B stronger than A. So it's more likely to correlate with that sort of thing. Or if you want some sort of intensity scale, it would be correlating with an intensity scale. So you may have your concentrations. Do they correlate with the scores on an intensity scale? Because instruments should correlate with intensity, basically, because that's what they measure. Instruments don't measure liking, they measure intensity. So they should really correlate with intensity measures. If you're doing that, by the way, don't expect a straight line. People use the correlation coefficient R, but often you don't get a very good correlation that way. Use a ranked correlation coefficient like Spearman's rho, and then you'll get sort of, a nice correlation coefficient of 1 or something like that. That is the relationship between the intensity measured on an instrument and intensity measured by people. So the instrumental intensity is your x-axis, your y-axis is an intensity score. If it continues to go up, it may be a curve. but your ranked correlation coefficient will give it a coefficient of 1 if it keeps increasing like that. But you're very unlikely when you get a curve to get a good correlation with your normal correlation coefficient. So use a non-parametric one. Don't use R, use rho. Okay, all right. But then if you're correlating liking with, basically liking with an instrumental score, probably liking you could correlate as well with an intensity score of people, in fact, because that would be the middle thing. But because maybe it feels more intense because it's got a higher concentration, there's not necessarily any relationship between the higher concentration and liking at all. I mean, there might be, but it would have to be, first of all, through the intensity. That is, people notice it's a higher concentration, then do they like it? But you could have just given them the higher concentration and see whether they liked it or not. Do you see what I mean?
Mm-hmm.
So that would be for something simple. On the other hand, if you're doing, you can pull out pretty well every chemical that's in that food, in fact, then they're going to blend, so there's going to be some sort of sensation which is not going to be tagged on one particular chemical. It's a whole mixture of chemicals and things. But again, you can see, does it taste more intense or whatever? Or you can fiddle around with various constituents and see, does it taste stronger, does it taste sweeter, does it taste whatever? And yeah, and then bear in mind that's the intermediate. And then give the preference test to people. Make sure, though, that when you're giving a preference test to people, that the things are different enough to be able to distinguish nice and easily. Because if people can't distinguish them, they'll give them a preference, in fact. So they don't have to be identical to get this funny placebo pair effect. If they're close and people aren't really sure they can tell the difference, they'll often still give you a preference. But that's the same thing as they're giving it with identical pairs. So it's good to check before you do a preference test that the people can actually tell the difference easily. And that's why that triadic one is quite useful, because if they're meant to say two are the same and one is different. Well, if they said the different one was one of the two placebo pair, they can't tell the difference. You've eliminated them, they can't tell the difference. They've failed their triangle test, or you would give them a triangle test after just to check, really. But it's interesting that people do give preference tests when they're not even sure whether people can tell the difference. And because people will give you a preference even when they can't tell the difference, they think, oh, well, that's perfectly all right. But it's not. What people do, what people say, isn't really what people feel. I mean, a person can say, oh, I'll definitely go out and buy that. Well, you're naive if you believe them. You want to make check that they really did. We want to check what is the behavior that tells you that they're going to buy that, and we don't really know that yet. Do they squitch a bit and pull a funny face or twitch when they're saying how much they like it? Does that mean they're going to do it? I mean, sometimes people say, oh, I really like this. Hey, where can I get it? Well, that would make me think a little bit more that probably the person's going to buy it. But after they've sort of walked out the room, they may change their mind, or they may not bother. To nurture or something like that. Really. So it's a chance thing whether people change from their regular product.
Mm-hmm.
Yes, so yes, lots of people correlate like that, but bear in mind the intermediary is not just, it doesn't go straight from the instrument to liking. It goes from the instrument to a measure like intensity. And then after that, people judge whether they like the intensity or not, or whatever it is that's changed, or the flavor, basically. So that's where the real work is. So if you find no connection at all, it doesn't mean you've done anything wrong or you've failed. It just means there's no connection. And that's a success. You told other people not to bother looking for the connection.
Mm-hmm. Thank you.
Okay. Are you doing a PhD or something like that?
No, I work on tomato flavor project. It takes a few years to develop a new tomato.
Okay.
And we try to model consumers to get the secret recipe for the next best tomato.
Okay. Oh, so that's okay. So failing along the line is okay because it's just telling people this is not the right recipe. So it's okay. Yeah. With some people have this pressure that they've got to come up with something exciting for their PhD. And they think they will fail if they don't do it. But in fact, that's silly. If you don't come up with the answer, it depends on, how you've done the experiment, what your reactions were, et cetera, what you did next when it didn't work, et cetera, et cetera. And that tells you whether you're a good scientist or not. So if you discover nothing in a PhD, it's okay, because it tells the people who come after you, okay, don't go this way.
Okay, well, thank you. With that, we are out of time.
Oh,
so, yes, an hour has gone by. And yes, so we thank you so much for your time and being open for the question and answer session. And so this is recorded. So for those of you who are on the call, feel free to share it with colleagues. And we will also be sharing this online through the IFT Connect and on LinkedIn.
And please explain, Omani had a bit of a cough this morning. He was going all the time. Which is, I could have muted it.
So,
me doing this, and they'd wonder why I was doing it. But still, anyway, there we go.
Yeah.
Thanks, Mike, for everything. Thanks, Catherine.
Thank you.
Bye-bye.
You're very welcome. Thank you, and congratulations again for all of the work that you've done for the field.
Okay, thank you very much. Thank you. And thank you for coming. Bye.